Assalamualaikum everyone. Today we'll be talking about atomic structure. Atoms actually are a concept that you must have been seeing for quite a while now. And let's start with a very rundown definition of atom, which is an atom is the smallest particle on this planet, right? I would like you to imagine atoms as something that make up everything, every non-living thing. Okay, for example, if you are sitting on a chair right now, just imagine the chair is this. If you break that chair down to its very smallest unit, that would be one atom of that chair. Okay, so atoms are actually the building blocks of non-living things. They are the simplest form of a non-living thing. Pretty much like cells are the building blocks of all the living things. Okay, if you talk about the structure of an atom, it's pretty simple. At the center of an atom, there is something called a nucleus. There's something called a nucleus. Okay, and around that nucleus there are different shells. There are number of shells, shell number 1, shell number 2, and so on and so forth. Okay, now within the nucleus and around these shells there are certain subatomic particles. What are subatomic particles? They are particles that are present inside an atom. Subatomic particles, we name them protons, electrons, and neutrons. Well, there can be a fourth one actually. You can call it a moron, but I hope that doesn't apply to my audience. Anyway, just moving on. So, protons and neutrons are present inside the nucleus, and electrons are present around the not around the nucleus, but along the shells. Okay, so let's talk about their charges and masses. Okay. So let's talk about the charge, their mass, and their location. Like location, I've already told you. So the charge on a proton is +1. That's why P for positive, P for protons. The charge on an electron is -1, and the charge on a neutron is 0, since it is neutral. Neutron means neutral, it comes from neutral. Mass of a proton is 1, mass of a neutron is 1, mass of an electron is 1/1861840, which is approximately equal to 0. Location of a proton is the nucleus. Location of a neutron is the nucleus, and the electron is shells or orbitals. Okay, so the important thing here is to remember that only protons and neutrons have appreciable mass. Okay, electron has negligible mass, so we can actually consider that electrons do not have any mass in a nucleus. So all the mass of an atom is due to protons and neutrons. Electrons do not have any contribution. If there is a contribution, there is a very insignificant one. So we just consider that only protons and neutrons are responsible for the mass of an atom. That is called an atomic mass. Which is mass of an atom. Which in other words are number of protons plus neutrons. Electrons do not have any mass. We cannot say any mass because they have negligible mass. So all the mass of an atom is due to protons and neutrons, and by extension we can also say that all the mass of an atom is concentrated inside the nucleus. Right? So moving on, atomic mass is also known as, it also have other names like nucleon number. Okay. Do not get confused if they say nucleon number. Nucleon means protons and neutrons. Since they are present inside the nucleus, they are called nucleons. And they are also known as mass number. mass number. Okay. So that is the concept of atomic mass. There's another thing that you should be familiar with, that is called atomic number. Atomic number is also known as proton number. Why? Because atomic number is actually number of protons. It is extremely important. Atomic number is extremely important. Why? Because it actually tells you about the identity of an element. It is the DNA of an element in the sense that it identifies an element. Every element on the periodic table has a unique atomic number, and through atomic numbers we identify elements. Okay, for example, if I tell you there is an element X with atomic number 1, you would go to the periodic table and see which element has atomic number 1, and you will only find one element, that is hydrogen. Okay, so moving on to the next point. Okay, so how do we calculate? We need to know how do we calculate neutrons. But before that, okay, if you have seen the periodic table, elements are written something like this. For example, if the sodium is written as 2311, potassium will be written as 3919. So what I'm trying to say is, if you go to the periodic table, with every element, with the symbol of every element, there are two numbers. One of them is atomic mass and the other one is atomic number. So how do you identify that which is which? You can simply evaluate from the magnitude of the number. The bigger value, always remember, the bigger value will always be atomic mass. Bigger value will always be atomic mass. Why? Because atomic mass is protons plus neutrons. Okay, and atomic number is only protons, so it will be a smaller value. Okay, that would be atomic number, which in other words means 23 is actually protons plus neutrons, 11 is protons. In this case, atomic mass is 39, so protons and neutrons, the sum of protons and neutrons is 39, and 19 is the atomic number, which is the sum of protons. So how do you calculate the number of neutrons? How can we calculate the number of neutrons? Calculating neutrons. How can we do that? So let's take the example of sodium. So 23 is what? Is protons plus neutrons, and 11 is protons. So how do we calculate neutrons? You can simply subtract this from this. 23 minus 11, which is proton plus neutron minus proton. So you will get neutrons equal to 12. So to calculate neutrons, you just have to subtract the smaller value from the bigger value. You just have to subtract atomic number from atomic mass. So the neutrons for potassium would be how many? 2. So the type of question that come in exams, the basic question that come in exams is like this. They will tell you an element like let's say calcium 40-20. They'll ask you about the number of protons, neutrons and electrons. How many protons are there? Protons are 20. That is the atomic number. What about electrons? For a neutral atom, always remember, for a neutral atom, what is a neutral atom? Neutral atom means that does not have any charge, like this. It does not have any charge. Always remember, protons are equal to neutrons. Okay? So, whenever there is no charge, protons are always equal to neutrons. Oh, sorry, electrons. Protons and electrons are always equal. Protons carry plus 1 charge, electrons carry minus 1 charge. So, this plus 20 and minus 20 actually cancel each other out. That's why calcium has no charge. Okay? And how do we calculate neutrons? We can subtract 40 minus 20. The answer would be 20. Let's do another example. Oxygen, no, that is a similar. Let's do fluorine. F199. How many protons? 9. Atomic number is 9. How many electrons? Since it's neutral, so electrons would be 9 as well. And how many neutrons? 19 minus 9, 20. Sorry, 10. What's happening to me? It's basic maths. Okay. Okay. These were writing subatomic particles for a neutral atom. Let's talk about what happens in charged atoms. Happens in charged atoms, which in other words known as ions. Ions are what? Charged atoms. Okay. When an atom loses an electron, it develops a +1 charge. So when an atom loses an electron, it develops a +1 charge. And whenever an atom gains an electron, it develops a -1 charge. If it loses 2 electrons, it will develop a +2 charge. If it gains 2 electrons, it will develop a -2 charge. Okay? So, for example, if I say that Na is +1, right, what does this mean? It means that 1 electron is lost. Okay? So, many students get confused that +1 means 1 electron is being added. No, it's not that. See, electron is negatively charged. So whenever an atom loses an electron, it will develop a positive charge. It's pretty much like, for example, if you have a negative person in your life and if that person leaves, your life will become positive. So if you compare that analogy with the situation at hand, you can see that electrons are actually the negative people in the lives of atoms. So when electrons leave, atoms become positive, and when electrons are gained, the atoms become negative. Sodium +1 means it has lost an electron. Okay, so how would we write the subatomic particles for 23 for sodium ion? So protons would be the same, 11. You cannot change protons because if you change protons, you change an element. How many electrons? Now this is not a neutral particle. If this was neutral, there would have been no charge. If there would have been no charge, protons would be equal to electrons. But in this case, sodium has +1 charge, which means it has lost an electron. Do not add 11 plus 1. Do not do 11 plus 1 and write 12. +1 means 1 electron is lost. You'll have to subtract it from 11, which will be 10 electrons. And how many neutrons? 12. Let's do another example. Calcium ion, Ca2 plus 40, 20. Okay. How many protons? 20. How many electrons in this case? 2 electrons are lost. Originally there were 20 in the atom, 2 were lost. So remaining were 18. What about neutrons? Neutrons are 20. Okay, let's do a negative ion. Let's do sulfur. 16, 32 and 16 minus 2. How many protons? 16. How many electrons? In this case there is -2. Do not do 16 minus 2, 14. Minus 2 means 2 electrons are gained. So electrons will be 18. Okay, and how many neutrons? 16. So that's how you write the subatomic particles of a charged atom. Okay, charged atom are called anions. When an atom loses an electron, develops a +1 charge. Positive ion is basically formed. Should know that positive ion is formed, that is called a cation. Positive ions are called cations. And negative charge जब आता है तो negative ion is formed. negative ion is formed. It's called an anion. Okay, moving on. So far we have discussed that protons do not change. Okay, but when electrons change, but electrons can change, right? And when electrons change, ions are formed. Okay, and similarly, neutrons also change. And when neutrons change, isotopes are formed. Isotopes are formed. What are isotopes? They are atoms of an element with same number of protons, but different neutrons. Protons are not going to change anyway. So in this case of isotopes, neutrons change. Okay, almost all the elements exist in the form of isotopes. Some are more abundant than the other. For example, hydrogen exists as 3 isotopes. There is H11 called protium, H21 called deuterium, and H31 called tritium. Okay, so how many protons? 1. Proton 1, because it cannot change, it's atoms of the same element. How many neutrons in this one? 0. How many neutrons? 1. How many neutrons? 2. So protons are remaining the same, but neutrons change. That is the definition of isotopes. Now if you look at the periodic table, you will find this guy. You will find this guy in the periodic table. Why? Because it is most abundant. Okay, so in element can exist more than one isotopes. They have more than one forms, as in the neutrons change from one atom to another, but they still belong to the same element. Like in this case, neutrons are changing, but protons are not, which means that these are atoms of the same element, and we call them isotopes. Okay, so the last topic of this chapter is something called electronic configuration. What does it mean? It means arranging electrons in different shells according to their capacities. So you should be familiar with 4 shells. 1, 2, 3 and 4. Obviously they have names like K, L, M, N, but you are not supposed to know them. You are not required to know them, but you are supposed to know them. K, L, M, N. Okay, so the first shell, first, second, third and fourth. Okay, the first shell can take a maximum of 2 electrons. Okay, try it. Oh God. Okay, let me just erase it. Take a maximum of 2 electrons. Second shell can take a maximum of 8 electrons. Third shell can take a maximum of 18 electrons. And fourth shell can take a maximum of 32 electrons. But remember that third shell, although third shell can take 18 electrons, but it only takes 8. It only takes 8 electrons. It does not fulfill its full potential. The answer lies in the details, and the details are buried in the syllabus of A levels. I think you should not open that can of worms. For you guys, it must be a can of worms. So just focus on the fact that third shell, although it can take 18, but it only takes 8. It's pretty much like many of you can get an A star, but not many would get an A star. A lot of you will get a B because you will not be fulfilling your potential. Okay, so I hope that you do fulfill your potential and do not be like the third shell of an atom. Okay, so third shell can take 18, but it only takes 8. Remember that. Okay, so let's do electronic configuration. First shell takes 2, second shell takes 8, third shell takes 18, fourth takes 32, but third में 80 जाएंगे. Maximum you are asked to do electronic configuration of elements up to 18 atomic number. In fact, 20 atomic number. You will just be required to arrange a maximum of 20 electrons. So let's do that. Let's do calcium 2 plus 40 20. How many electrons are there? Originally there were 20, but there's a plus 2 charge, which means that 2 electrons are lost. So 18 electrons are there. So its electronic configuration would be 2. First cell will take 2, second will take 8, third will take 8. Electrons were 18. So that would be its electronic configuration. Okay, let's take another example. Fluorine 19, 9 minus 1. It has gained an electron. How many electrons are there? 10. So it would be electronic configuration would be first shell will take 2, second will take 8. Okay, let's do potassium 39, 19. So how many electrons? 19. It's a neutral atom, so protons are equal to electrons. And its electronic configuration would be 2, 8. 2 shells are complete. Third shell can take 18, but it only takes 8. And one remaining electron goes to the fourth shell. Similar is the case with calcium. Calcium 40, 20. Its electronic configuration will be 2, 8, 8 and 2. So that was the end of the chapter. Now let's apply these concepts to solve some past paper questions, and I hope that it will cap up your lesson and will prepare you nicely. Okay, so question number 1 states that a particle contains 34 protons, 45 neutrons and 36 electrons. Which symbol is correct for this particle? As you can see, there are 2 more electrons than protons, which means there will be a minus 2 charge. There will be a minus 2 charge. Where is the minus 2 charge? There you go. You don't even have to check other things to solve this question. Question number 2. A radioactive isotope of carbon has more nucleons than the non-radioactive isotope. This is the non-radioactive one. There is a radioactive isotope which has more nucleons, which means that its atomic mass will be greater than 12. And if its atomic mass is greater than 12, it means that the radioactive isotope which we was talking about will have more neutrons, because protons do not change, so neutrons will have to increase the nucleon number or the atomic mass. So how many protons, neutrons and electrons could there be in this radioactive isotope of carbon? So protons has to be 6. So C and D would be wrong because it's an isotope of carbon. So there has to be 6 protons. How many neutrons? So this is incorrect because he himself said that the radioactive isotope of carbon has more nucleons. More neutrons means more neutrons because protons do not change. So A can't be it. It has to be B because there's more neutrons. The symbol for 2 ions is shown below. This statement is correct. C. 2 ions contain the same number of electrons as each other, which are 10. 9 plus 1, 11 minus 1. An oxygen atom contains 8 electrons, 8 protons and 10 neutrons. What is the nucleon number of this atom? So, what is the nucleon number? Proton plus neutrons. D. 18. An atom X contains 16 protons. Which statement about X is correct? It cannot form an ion. It can if there are 16 protons, and it's an atom by the way, it's not an ion, which means if there are 16 protons, there are going to be 16 electrons. In the electronic configuration, 16 electrons is 2, 8 and 6. So it can form a minus 2 ion. It can form an ion with minus 2 charge by gaining 2 electrons. Okay. So, let's not get into that. I haven't studied yet. But 286 is the electronic configuration. It can form anion, so A can be it. It contains 6 electrons in its outermost shell. That's correct. That's the concept he's testing right now. This statement about both chlorine atoms and chloride ions is correct. So what are they? They have the same number of protons because both are chlorines. Hydrogen can form both H plus ions and H minus 1 ion. Which one of the statement below is correct? An H plus 1 ion has more protons than an H minus 1 ion. No, protons do not change this kind of thing. And hydrogen ion has no electrons. Okay, H plus 1 ion has no electrons. So H21 plus 1. So yes, it had one electron and that was also lost. So B would be correct. An element X forms a positive ion with the electronic structure 288. So that positive ion, some positive ion has the electronic configuration 288. Okay. What is the proton number of X? So proton number of X is actually equal to the number of electrons of the neutral X. Okay. So if the positive ion that X forms have this electronic structure, it means that it must have greater than 18 electrons. It must have greater than 18 electrons because it has already lost an electron. Again, 1 or 2 or 3 electrons is already lost. Okay, because it's a positive ion, and after losing it has these much electrons. Okay, so the answer cannot be less than 18 or 18. Electrons have to be greater than 18 for its proton to be greater than 18. Okay, if X plus, I'm repeating again, if a metal ion has electronic configuration equal to this, okay, then they're asking you about the proton number of X. Proton number of X. So it means that it has lost electrons become this. It means that the electronic configuration of X will have more electrons, which means it will have more protons as well, because protons is equal to electrons in a neutral atom. The answer would be D. This diagram shows how the particles are affected by the plates. So electron must be deflected by positive and proton must be deflected by negative. The answer would be D. So we already done this. Let's do this. Number of electrons, how many? This neutral atom, electrons would be 87. And number of protons, number of electrons, and number of neutrons. Okay, so he is telling you the table shows information about 2 isotopes of francium. So this is also an isotope of francium. So protons to hi rahenge. Okay, and the neutrons are 138. Neutrons are 138. How many electrons will be there? Electrons will also be equal to 87 because it's a neutral atom and you don't have any other information to justify that. Anyway, describe how francium ion and an oxide ion are formed from francium atom and an oxide atom. Francium is +1, O is -2. So you can say that francium atom loses an electron to form Fr +1 ion, and oxygen atom gains. In fact, francium atom loses one if there are 2 atoms of francium. So okay, they're just saying that how francium and oxide are formed. Okay, and oxygen atom gains 2 electrons, one from each francium atom. We'll get to that once we study chemical bonding. That how does this work? You will get this question there as well. We each from each Fansham atom. Okay, this question was a bit premature in the sense because it belonged to another chapter. It is testing the concept that you must know about chemical bonding. What is the nucleon number of F? 22 plus 18 to be 40. Explain why A is a neutral particle. A has equal number of protons and electrons because number of electrons are equal to number of protons, which balance the charge. Is the charge on atom. Which particles are isotopes of the same element? We'll have to watch out for particles which have same protons but different neutrons. Which have same protons? Let's check that out. So these two have same protons and these two have different neutrons. So C and D have to be the isotopes. What is the charge on E? What is the charge on E? E has 2 more electrons as compared to protons. The charge would be -2. The charge on E would be -2. Which particles have the same mass? So just add protons and neutrons. This seems to be F and G. 22 plus 18 is 40. 20 plus 20 is 40. So F and G have the same mass. Okay. That is a repeating question. So let's do this one as well. Which particle has only 20 protons in its nucleus? Calcium. A. Which particle has a nucleon number of 35? 35. Nucleon number of 35. Cl3517. Nucleon number 35. Cl3517. Which particle has an electronic structure of 288, which means it must have 18 electrons. Okay, this has 20. This has 18 electrons. Cl minus 1, 37, 17. So I hope you enjoyed the lesson and got what you needed and understood all the major concepts. I hope you will be able to do all the past papers, at least most of them. Okay then. Allah Hafiz, see you later.